This is the final spacecraft to ever touch down on the scorching surface of Venus. It was part of a daring series of Soviet missions that pushed the boundaries of human engineering into the most unforgiving environment in the solar system. This is what the Soviets discovered when they braved the hellish world of Venus, and why, for over 4 decades, no one has returned to its surface. Venus, our closest planetary neighbor, shares so much with Earth. Nearly the same size, mass, and composition, born from the same cosmic neighborhood. Yet it stands as a stark warning, a twin transformed into a nightmare. Its thick shroud of clouds hides a surface hotter than molten lead, crushed under pressure that would implode a submarine. How did a world so similar become so catastrophically different? In the early space race, while Mars captured dreams of ancient canals and potential life, Venus intrigued scientists more. Telescopes revealed Mars' barren, visible surface, but Venus remained veiled, its dense atmosphere hinting at Earth-like qualities, or something far worse. Even in the 1950s, visionary astronomers like Carl Sagan warned that those impenetrable clouds might trap heat in a runaway greenhouse effect, turning the planet into a superheated inferno. Others dreamed of steamy jungles teeming with life beneath the veil. There was only one way to pierce the mystery: send probes. The Soviet Union, riding triumphs like Sputnik and Yuri Gagarin's flight, seized the challenge. Venus became their obsession, a chance to claim historic firsts in the Cold War's shadow. In 1961, the Soviets launched Venera 1 and 2, paired for redundancy in an era of high failure rates. Primitive by today's standards, these probes relied on basic calculations, strapped atop modified ballistic missiles. Both reached Venus's vicinity, but succumbed to overheating and communication failures, yielding no data. Undeterred, as NASA prepared its own flyby, the Soviets refined their designs. Then, in 1962, NASA's Mariner 2 swept past Venus, scanning from afar. Its instruments confirmed Sagan's fears: surface temperatures soaring to 430 degrees Celsius, far beyond boiling water, with clouds towering 80 kilometers high, stretching from ground to space on Earth. No life could survive. The atmosphere was crushingly dense, laced with carbon dioxide. NASA, deeming Venus inhospitable for machines or humans, shifted focus to the Moon and Mars. But the Soviets saw opportunity. With America stepping back, Venus was theirs to conquer. By 1967, the space race had evolved. America aimed for lunar landings, but the Soviets doubled down on Venus with heavier, tougher probes. Venera 3 and 4. Venera 3 crashed into the planet, the first human object to impact another world, but silent. Venera 4 fared better, deploying a descent capsule that parachuted through the atmosphere, transmitting the first in situ data from another planet. As it descended, readings painted a chilling picture. High up, conditions mimicked a pleasant Earth day, but deeper, temperatures skyrocketed, pressure built like plunging into ocean depths. After 93 minutes, signals ceased. The capsule likely crushed at around 25 kilometers altitude, where pressure hit 20 times Earth's. Yet the data revealed an atmosphere 90% carbon dioxide with traces of sulfuric acid. The lower layers were a toxic soup. This knowledge shaped Venera 5 and 6 in 1969. Reinforced for deeper descent, they lasted under an hour each before succumbing. Pressure exceeded 100 atmospheres. Temperatures neared 400 degrees Celsius. Engineers realized surface landings demanded radical redesigns. Thicker shells, better cooling. As Apollo 11 triumphed on the Moon, the Soviets pivoted to planetary probes, seeking legacy beyond lunar defeat. Venera 7 in 1970 marked a breakthrough. Its parachute tore or melted during descent, plunging the capsule like a meteor. It slammed into the surface at high speed, tumbling and damaging its antenna. Mission control assumed failure, but faint signals emerged. The probe survived, transmitting for 23 minutes. Surface temperature, 475 degrees Celsius, hot enough to melt lead. Pressure, 92 bars, equivalent to 900 meters underwater on Earth. No paradise, a furnace under crushing weight. The revelation stunned yet fueled determination. Venera 8 in 1972 landed intact, operating for 50 minutes. It measured light levels, dim but sufficient for photography, and confirmed sulfuric acid clouds. Gamma-ray spectrometers analyzed soil, basaltic rock, volcanic in origin. Venus was a world of fire and stone. By the mid-1970s, designs evolved dramatically. Venera 9 and 10, weighing nearly 5 tons, used disc-shaped aerobrakes to slow through the dense air without parachutes, minimizing exposure. In 1975, Venera 9 became the first to orbit Venus and deploy a lander that transmitted the first photograph from another planet's surface. Jagged rocks strewn across a hazy plain under a yellowish sky tinted by the thick atmosphere. Days later, Venera 10 revealed smoother terrain, ancient lava flows solidified into flat basalt. These black and white panoramas, though grainy, evoked profound alienation, a barren, windswept wasteland under perpetual overcast. No life, no water, just desolation. Venera 11 and 12 in 1978 faced lens cap failures, robbing us of images, but detected lightning and analyzed more soil. Then came the pinnacle, Venera 13 in 1981. Surviving over 2 hours, a record, it beamed the first color photos, orange-tinted rocks, a flat horizon fading into haze. Its drill sampled soil, revealing tuff-like volcanic ash. A microphone captured the alien wind, low howls and mechanical thuds, the first sounds from another world. Venera 14 followed, finding tholeiitic basalt akin to Earth's ocean floors. Vega 1 and 2 in 1985, en route to Halley's Comet, deployed balloons floating in the atmosphere, and landers that confirmed the hellscape. These were the last surface touches. Vega 2's lander operating briefly amid 465 degrees Celsius heat and corrosive acids. Why stop? The Soviet program ended amid economic strain and shifting priorities as the USSR collapsed. Building probes to withstand Venus briefly was heroic but costly, yielding hours of data versus years from Mars rovers. NASA post-Magellan radar mapping in the 1990s, revealing vast volcanoes, lava plains, and possible recent activity, avoided surface missions, deeming them low return. Yet Venus whispers profound lessons. Its runaway greenhouse, 96.5% CO2 atmosphere trapping heat, mirrors Earth's potential fate if unchecked. Recent analyses of Magellan data show active volcanism, lava flows that change between orbits. Japan's Akatsuki orbiter, studying since 2015, tracks super-rotating winds and mysterious cloud absorbers, hinting at unknown chemistry. As of 2025, Venus awakens renewed interest. NASA's Da Vinci probe will plunge through the atmosphere, sampling noble gases and imaging in descent. Veritas will map surface emissivity and topography at unprecedented resolution. ESA's Envision, with advanced radar, probes subsurface layers. These orbiters and probes, launching in the 2030s, promise to unravel how Venus lost ancient oceans, why its tectonics stalled, and if phosphine traces suggest life in temperate cloud layers. The Soviets' grainy images remain our only direct glimpses of the surface, a testament to human ingenuity against impossible odds. Venus, so close, so similar, yet a cautionary twin. What secrets still lurk beneath those clouds? As new missions rise, we stand on the cusp of revelations that could redefine our place in the cosmos and our planet's fragile future. What aspect of Venus captivates you most? Its volcanic fury, atmospheric mysteries, or lessons for Earth's climate? Share your thoughts below, explore more cosmic wonders, and join the journey into the unknown. Information updated.